Hello everyone, in this particular video we will be trying to solve the prime number using more ways. One of the way to solve prime number is skipping even numbers. So what we can do here is that we very well know that the multiples of 2 won't be prime. 2 is the only even prime number. All other even numbers are not prime. Hence, what we can do here is that check only the odd numbers. So if n is 2, we return true. Otherwise, if n is less than 2 or a multiple of 2, we simply return false. And we start checking from 3, then we check 5, then we check 7, then we check 9. And in that I put a square root condition. So I'm only checking odd numbers up to the square root of n. We already have learned how to check up to square root of n. In that I optimized it further by only checking up to square root of n for odd numbers only. I'm not checking even numbers at all. Another optimization is sieve of Eratosthenes. It is for all the prime numbers less than equal to n. What we are going to do here is this. Let's say for 18 I have to prove whether 18 is a prime number or not. I will start with 0. I mark it false because it is not a prime. 1 is also not a prime number. I mark the first number 2 as a prime, and all the multiples of 2 are marked false. 4, 6, 8, 10, 12, 14, 16 and 18 are marked false. Then I go to 3. I mark it true, the leftover one, and all the multiples of 3 I will mark as false. Then I went to 4. 4 is already marked false. I will went to 5. I mark it true, and all the multiples of true I will mark false. Multiples of 5 I will mark false. Then 6 is already false. For 7 I will mark true, and multiple of 7 I will mark false. It is already marked. Then I will go up to the next one, which is 8. 8 is false, 9 is false, 10 is false, 11 I will mark true because that is empty, and all the multiples of 11 I will keep doing that again and again. In the end, I will find out that the values which are marked true are the prime numbers because all the factors are being cut out. So what we are gonna do here is this. I create a prime number array, 1 based indexing, hence it is n plus 1. Prime of 1 is marked as true, and 0 and 1 are marked as false because they are not prime, and I start from 2. Okay, I initially mark every one number as true, assuming I initially travel over the array and mark everything as true, assuming that everyone is prime. But everyone is not prime. The prime definition is either it divisible by 1 or by itself, nothing in between. So I go with 2 and all the multiples of 2, like I start from 4, I cross I, which is 4, and I keep increasing it by 2. So 4, then 6, then 8, then 10, then 12, then it comes to 3. So 3 cross 3 is 9. I start from 9, then 12, then 15, then 18. This is how the inner loop will run. And it will keep running. Then I will become 4. Since it is already false, it will skip further. It will skip further and I will become 5. 5 is a prime. 5 is marked true. And then all the multiples of 5. So 5 cross 5 is 25. I will start from 25 and then I keep increasing the loop by 5. So I start from 25. 25, let's say n is let's say 200. So 25, then 30, then 35, then 40, 45, 50, 55. All these are marked false. So all the multiples of 5 are getting marked false, and I keep repeating that. At the end, the numbers which are left as true are the only prime numbers. Okay, so if it is prime, true left, that means all the factors which are already marked false, that won't be printed, only the prime numbers will be printed. I can also optimize this sieve. How? I can optimize the sieve very simply, that I basically need to check for the fact that